It's relatively straightforward to work out centripetal force when considering horizontal circular motion, for example, like a car going round a corner. However, things get much harder when the circle is tipped so that it's vertical, because now you have to consider things like the normal reaction force and the weight of the object too. By the end of this video, you should be able to work out with confidence what is causing the resultant force in vertical circular motion. Centripetal force is not some strange force that appears out of nowhere, accelerating an object towards the centre of a circle. Rather, centripetal force is caused by the resultant force of other forces acting on the object as it goes in a circle. Start by removing the confusing resultant force. Since the car is right at the bottom of its journey, there are only two forces acting on it. One of those is the weight going downwards and the other one is the normal reaction force going upwards. The centripetal force is the resultant of these two forces in the direction towards the centre of the circle. Therefore, we can say that the resultant force upwards is going to be equal to the normal force upwards take away the weight force going downwards. When the car is at the top of its journey, the weight is still acting downwards, but also the normal reaction is now acting downwards. This means that the centripetal force, the resultant remember, is simply just the weight and the normal reaction added together. What do you think the centripetal force is in this example when the car is exactly halfway between the top and the bottom of its journey? Hopefully you're able to say that since the weight force is down at 90 degrees to the reaction force, these two forces are completely independent. And this means that the centripetal force at this point is just equal to the normal force. What about this case when a roller coaster is going over the top of the curb? What's the centripetal force this time? Well, same as before. Think about the weight, think about the normal reaction, and look for the resultant. Well, the weight's going down, the normal reaction this time is going upwards. Therefore, the centripetal force is simply equal to the weight take away the normal reaction. Suppose you have to find the resultant force when the car is not at a nice easy angle, such as the one I've shown here. The first thing you need to do is to actually define where the car is. In other words, we need an angle, and the easiest way to do that is relative to the vertical, as I've shown. As always, the reaction force is acting towards the centre of the circle, and the weight will be acting downwards, as per usual. Since the resultant force has to act towards the centre of the circle, we have a problem here. The reaction is lined up perfectly, but the weight is at an angle. So what we have to do is look for the component of the weight that is parallel or anti-parallel to the reaction force. This component will be mg cosine theta. This therefore means that the resultant force or centripetal force towards the centre is going to be equal to the reaction force minus mg cosine theta. Circular motion crops up all over physics, but what has circular motion got to do with simple harmonic motion, and where does that angle come from? I'm going to explain that and more in this next video.